it with the other function, we're going to do it again. We have to find the domain first. Can anyone factor x squared minus x minus 6 for us?
X minus 3, x plus 2.
Very good. The product is negative 6, the sum is negative 1. Good. Based on this, we have to identify the domain. Awesome. Thank you so much. Who was that? Kevin again. Okay. Very good. Thank you. So can anyone give us the domain now? Once we factor, now we have no problem in finding the domain. So what is the domain of this function? Anything but
Three and negative 2.
3 and negative 2, very good. Negative 2, 0, 3. I don't know the sign. So now I have to plug in negative 2.1, negative 1.9, 2.9, and 3.1. Can you use a calculator and plug them in? Yes, you can, but it's too easy. Negative 2.1, this is negative, this is also negative. Negative with negative 2.1, negative, negative. What is the sign?
Positive.
Perfect, thank you. Negative 1.9, this is negative, but this becomes positive. So this is negative and this is positive. Sign.
Negative.
Perfect. Now with 2.9, this is negative, this is positive. Sign.
Negative.
Perfect. And this is positive and positive, clear. Plug in 0, please. What do we get when we plug in 0?
Negative 1.
That's it. We're done. Not symmetric, I have to write f of negative x will never equal f of x, will never equal negative f of x. This doesn't change, this changes, it's completely different. Not symmetric. Perfect. Let's do that. Let's graph. Nothing matters, I don't care for anything. Oh, I didn't say let's find the y-intercepts because a fraction that has no x in the numerator cannot be 0. So I will only follow what I see. I'm not interested in anything else. Now this is an overkill, right? Because the x is already there. Okay. X equals negative 2. X equals 3. And now I'm ready. From 0 goes to positive infinity on the left-hand side of the first asymptote. Piece of cake. Asymptotically. Closer and closer. From negative infinity, crosses at 0, negative 1, goes back to negative infinity. Now, we do not know in this class, but I don't expect it to turn here. I expect the function to have another maximum there. We will use a calculator in a minute and we'll adjust it if that's the case. It could be this, but see, these are smooth functions. It will be kind of difficult for it to do this. It will make more sense to do this. If you have to twist your wrist to graph it, most probably is not going to be the case. We'll check in a minute. From negative infinity up to 0, negative 1, back down to negative infinity. On the right hand side of x equals 3, coming from positive infinity asymptotically, closer and closer to 0 asymptotically. So this is our function f of x, 6 over x squared minus x minus 6. Now, with the graphing calculator, be very careful how you punch in these functions, because if you do not put parentheses, when parentheses are required, the whole thing collapses. So 6 divided by, and in parentheses, I have to have x squared, and I have to have minus x minus 6. Now I graph the function. I know how it looks. I think I'm going to use the standard viewing window. Zoom standard. Okay. Of course, this is not the case, meaning the function does not overlap with the x-axis. That's not possible. But the calculator is not as sensitive as we are, and we understand what's happening. Do not graph or copy this graph, right? Now, the graph does not show the vertical asymptotes. We know they're there, and we know we have to graph them before we do anything. Now I'm going to focus on this little area, and I'm going to try to find the maximum. So between negative 1 and positive 2, I'm going to try and find the maximum in this area. So second and calc, I want a maximum. 4. I want, you can use left and right arrows. Let's do that. That's fine. I pass the maximum on the left. That's my left bound. I have to pass the maximum on the right. Make sure I passed it. Okay, enter. No, I don't want to guess. Just give me the answer. And as you see, the maximum is not on the y-axis. Is at 0.5. I'm going to write it here. So at 0.5 comma negative 0.96. And I put it on the graph as expected. Why? You may say, how do I know that? That's true. You may not, but you can check. But see how smooth I can graph this, how smooth I can graph this. If I have to do this, it's not natural. It doesn't mean that it cannot happen, but this is more likely. And this is type 2. What was the difference? Nothing from type 1. Just a little easier to find the horizontal asymptote. Much easier. I don't have to think. For the type 1 is the leading coefficient over the leading coefficient. But for type 2, easy. Okay.
Sorry.
Yes. Yes?
Why is it 0 again?
Very good question. Let me explain. We talk about this in calculus a lot. So see, when we talk about horizontal asymptote, we talk about the limit as x goes to infinity or x goes to negative infinity. So 6 divided by x squared minus x minus 6, when x increases so much without bound, this gets closer to infinity or negative infinity. 6 divided by infinity eventually goes to 0. We show it very nicely in calculus with the limit operator. The limit as x approaches infinity from f of x, it will be 0. And we show how and why. But we don't study this in this class, not yet. So when x increases without bound, this increases so much that when we divide 6 by huge, eventually we get 0. So that's why the function of type 2 eventually approaches 0.
All right, thank you.
Thank you. Very good question. Okay. Now I want to, most probably I will not be able to show an example with the slant asymptote, which I wanted to, because I want to emphasize one other situation. So if I have, for example, this function, you can immediately say, I know it's type 2, I know what you're going to say. You're going to say that the horizontal asymptote is what? The end behavior and the horizontal asymptote, you're going to say, well, I know it's what?
Yeah.
Yes, that is very clear. We understood that. Perfect. But here's a different situation that I would like you to pay attention to. When we try to find the domain, of course you have to factor the denominator. What would you say the domain is? The domain is anything but anything but
one and negative one.
excellent. Notice that I don't jump ahead and write the vertical asymptote yet for this function. Here's why. So what was different from before? I could not eliminate any factor. There was no factor that I could eliminate. And always remember the domain has to be stated on the raw function. There was no factor that I was able to eliminate. No factor, no factor. But here I have a factor that I can eliminate. I have to state the domain before I eliminate the factor, which I did. I realized that x cannot be -1 and x cannot be 1. But now, after I stated those restrictions, I can simplify, and this is my new function. I don't care for this anymore. It doesn't mean anything. This is my new function with these restrictions. I cannot change that. The factor that goes away creates a hole in the graph. The factor that stays still has to be a vertical asymptote. The factor that goes away becomes a hole in the graph because the function is still undefined. But you can say, but not this one. True, but we're not graphing that, we're graphing this. It turns out that I made my life easier and now I'm going to graph that. But this is the function I have to graph, and this function does not exist at 1 and -1. But because the factor goes away, this becomes a hole in the graph. But this is a vertical asymptote. So here I will immediately determine my asymptote, the signs. With 0.9, this is negative. With 1.1 is positive. That's done, right? With 0.9 and 1.1. But here, I have to plug it in. When I plug in -1, I get -1/2 on both sides. It has to be, because it's a hole in the graph, not a jump, a hole in the graph. And now, I have to plug in 0 and I get -1. That's it. I'm ready to graph. First, the asymptotes. Well, of course, this is an overkill because it's already there. Then I have x equals 1. And now I'm ready to graph. Here it is. And -1 is -1/2. Coming from 0, going through the hole, 0, -1, and going to -infinity. Nice and easy. On the other side, nice and easy, asymptotically getting closer and closer to the asymptote. So this is the graph of x plus 1 over x squared minus 1. This is a major topic, very important, even more than functions with slant asymptotes. Being able to identify, after you state the domain, you realize that this goes away, this factor goes away, but this is, because it goes away, is no longer a vertical asymptote. This factor stays, it is a vertical asymptote. The calculator, of course, is not as sensitive as we wanted it to be. So the numerator has to be in parentheses, and it has to be x plus 1. The denominator has to be in parentheses, and it has to be x squared minus 1. Okay. What I forgot to show is that if there is a horizontal asymptote other than 0, you have to put it in yourself as a secondary function. I'm going to put 0 because that's the horizontal asymptote. But you have to enter it separately by hand. Okay, so when I hit graph, it will say, what are you talking about? Yeah, but if I zoom in this area between negative 2 and 0, you will see it, okay? And between negative 2 and 2. Otherwise you will not. Here it is. Look at this, a little blimp in here, right here. Okay? But if I use the standard viewing window and you don't know what it is, you will never see it. I had to really, really zoom in to see that little open point. We call it removable discontinuity. You'll see that in Calc 1. Okay? So the calculator is not as sensitive. So this is a very important situation. I don't think we are going to have time today for a upload, but because I would really like to show as much as I can a slant asymptote situation. So forgive me for that. If you're present, you're going to get full credit for this today. You don't have to upload anything because I like to show a slant asymptote. Okay, so let's say we have here 16. So we have g of x equals x to the third plus 1 over x squared plus 2x. So what is different here? So this is type 3. So what is different here is the end behavior, because it's the slant asymptote. So we have x cubed plus 1. I know you're going to say factor out an x, and I know you're going to say negative 2, 0, infinity. There is no factor that I can remove. I know these must be infinities. We have to change. We have to decide on the sign. We'll do that in a moment with the calculator because it's more work. But I want to identify the x and y intercepts, and of course x cubed plus 1. So there is a 0 in there. Okay, I just want to discuss this. How do I find the slant asymptote, which will also be the end behavior? Okay, I divide. So I divide x to the third by x squared plus 2x. Notice that the requirement is just 1 degree more. 2, 3, 4, 5, 6, 7. Why? Because I have to get that line. How do I get that line? Dividing degree 3 by degree 2. I get a line. Dividing degree 10 by degree 9, I get a line. Otherwise, I will not get a line. If the degree here is 4 and this is 2, this is not category 3. It's not type 3. Okay, so how do we get that? Okay, so x squared times y is x cubed, whatever has to be x. X times x squared is x cubed, I subtract. X times 2x is 2x, I subtract. And negative 2x plus 1. And I cannot continue. So the quotient is y equals x. Just the quotient is the slant asymptote. Why? Because I know Kevin is going to ask, and he's right. Why? Why did you pick just the quotient? What about the remainder? Here's why. So, x to the third plus 1 over x squared plus 2x is x plus the remainder, negative 2x plus 1 over the divisor. And rightfully so, you're going to ask, where does this go? Where does it go? Why do you pick just the quotient to be the slant asymptote? For the same reason I explained a minute ago. Maybe not a minute ago, maybe more than a minute ago. Let me see. This piece goes to 0. How come? Because it's more powerful in the denominator. So when x approaches infinity, this piece goes to 0. For the same reason. Because the degree in the denominator is bigger than the degree in the numerator. At infinities, this will approach 0. That's why it's disregarded. So this is the slant asymptote. So the slant asymptote is this line, y equals x. So it goes to infinity here, and it goes to negative infinity here. That's what it is. If the answer were negative x, I would have written positive infinity here, and I would have written negative infinity here. But because it's y equals x, then it's infinity and negative infinity. And this is it. It's not an easy graph. It's not an easy graph. Let's graph it, and we'll stop. Here's the graph. When we graph functions with asymptotes, we have to start by graphing the asymptotes. So I write myself a note here, slant asymptote. Y equals x, slant asymptote. Then I have negative 2. And I have 0. Overkill, but just to make sure it's there. Good. And now I'm ready to graph this function. From negative infinity to positive infinity. Asymptotically, here it's approaching the slant asymptote. Here it's approaching the vertical asymptote. In the middle, from positive infinity, it crosses at negative 1, 0, and it goes back to positive infinity. This may happen, right? Because there is only one solution, 1, 0. It cannot cross because there is only one x-intercept. Now on the other side, from positive infinity to positive infinity, asymptotically, meaning getting closer and closer, closer and closer. And this is the graph of g of x, x cubed plus 1, x plus 2. Not a friendly function, as you see. So we check, clear everything. The second function must be y equals x. The calculator will not graph your slant asymptote or horizontal asymptote if you don't put it in by hand. Don't forget parentheses around the top. X to the third plus 1, and divide by x squared plus 2x. Close. I will not change the viewing window, maybe, maybe not. I'm going to try to see if if the minimum on the right hand side shows up. I would use the standard. If it doesn't, I have to make adjustments. I have no idea what I entered. I entered everything correctly. Square plus 2x. And y equals x is there. Okay, let's see it again. Oh, I didn't, sorry. I didn't establish my, I don't understand what this is going on here. We'll see in a moment. Why is this? I don't understand what this is, but here's what I did. What I didn't do, I rushed into, I did not establish the signs. Sorry about that. I considered everything was positive, but that's not the case. Sorry. I jumped into finding the slant asymptote, but I didn't determine my signs here. Okay. So let me just put them with a calculator so we can. Sorry about that. I jumped into conclusions without thinking. Okay. So I just I'm gonna delete this for a moment in the sense that I'm just gonna de-highlight it, and I'm just gonna plug in my numbers. Negative 2.1. That is negative. Okay. I have to put a negative here. Then I have to plunge in negative 1.9, and that is positive, and then negative 0.1, and that is negative, and finally with 0.1, and it's positive. Okay, so now I have to graph my graph from scratch. I don't want to hold you. It's 8:01. If you need to leave, please leave. I'm just going to record myself finishing it up because I don't want to leave it like this. But if you have to leave, please do so. I will not be offended. Okay, so I have, first of all, y equals x. I'm checking my, did I do anything here? X squared plus 1. So it's x squared negative 2. So this is what happened. So x is negative 2x squared, negative 2x squared. Okay, plus 1. So I do have minus 2. That's what it was. So negative 2x squared, positive 2x squared, and minus 4x plus 4x. Got it. So this is x minus 2. Okay. And the numerator is 4x plus 1. Perfect. Sorry about that. Okay. So then the slant asymptote is x minus 2 when x is 0, y is negative 2. When y is 0, x is 2. Got it. So here are the asymptotes. So here's the slant. Y equals x minus 2. Then we have x equals negative 2 and x equals 0. Good. Okay, one more time. From negative infinity to negative infinity. I'm checking now, so this was again negative infinity to negative infinity on the left hand side. We checked this was negative. The middle part comes from positive, crosses here, I got it. And on the other side of the vertical asymptote. And on the right hand side from positive infinity to positive infinity. We can determine this maximum with a calculator. In calculus, you wouldn't be able to determine it without the calculator. And we can determine this minimum with the calculator. Okay. So again, thank you so much for your patience. I hate to do this. It's as a token of respect to you. I just wanted to finish it. And we can talk about it again on Wednesday if that's what you want. So x minus 2. Oh, I should have not deleted that, sorry. So x cubed plus 1 and everything divided by x squared plus 2x. Okay, so again I will use the standard. Okay, much better. As you see, the vertical asymptote at -2 is missing, but we know it's there. We know that the graph cannot end here, that's not possible. So it's a smooth, continuous portion and it goes all the way to -infinity. We know that the graph cannot start here or end here. We know it's coming from -infinity, coming down to a minimum and approaching the asymptote asymptotically, and the same thing here. Can I determine this? Yes. With second and calc, I want to find the maximum. And I'm going to say -4. No, -4 may not be a good idea. So I'm going to try again. So I'm just going to move it, make sure I moved it past. And make sure I move it past. Okay, and I have the maximum now. And that is at -3.9. So this point, -3.9, comma, -7.87. And in the same way, I will determine this minimum with second and calc. And I want a minimum this time, which is a 3. And I want point 2. Yeah, that's good. I want to pass the minimum. Pass the minimum. And I want the minimum. And the minimum is 0.92. 0.92, comma, 0.66.